Number 6, this is a physics problem. F of t represents the position of an object in free fall. All right. So when we have an object in free fall, it falls at a constant rate of acceleration. Well, it's 9.8 if we measure in meters. If we measure in feet, it's 16 feet per second.
Okay, so it'd be negative 16 feet per second.
Well, it would be. It depends. So it depends on how you orientate what's negative and what's positive. But this is the function that shows us the distance that the rock travels. Okay? And so what we want to know is the speed. Well, the speed, as you guys recall, was the rate of change. Right? So it's the rate of change of position. So what I need to do basically is find the rate of change of this thing. So let's talk about that and we'll unpack it. The rate of change of this function is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h as h approaches 0. Now before I start plugging things in, what I want to point out is that f of t is equal to whatever t is squared times 16. Well, I've got to plug two things in. I've got to plug in a plus h. So if I plug in a plus h, then I would plug in a plus h here. I also need to do f of a. So f of a would be very similar. That one's the easy one because we're just plugging in the a instead of the x. But this is all based on f of t is equal to 16t squared. So before I move any further, do you guys get that? Does that make sense?
Where are you going to get a from?
Oh, it tells us that t equals 1 is the question. What is the speed after 1 second?
We're using t as a.
Well, yeah, eventually we'll plug in, yeah, so this means that a will equal 1 at some point in time. Does that make sense? So the question in the textbook says, look, this is the equation of position. We want to know when we drop a rock from the top of a building at 1 second later, what is the speed of the rock? Well, we know that speed is the rate of change of the position, and this is the position function. So if I find the rate of change of the position function at t equals 1, then I'll know the speed. Does that make sense? So now before I can plug the stuff in, I have some composite functions that I need to take care of. Because I need to know the limit of f of a plus h minus f of a all over h. So what we end up with is the limit as h approaches 0 of 16 times the quantity a plus h squared minus 16a squared all over.
Plus or minus 16a squared?
It's minus, because it's minus f of a, right? So now to do the next step, what I want to do is I will say the limit as h approaches 0 of 16 times, if I expand that, that's a squared plus 2 times a h plus h squared minus 16a squared all over h squared. Or just h, I'm sorry. So next thing I need to do is we want to expand this because we'll probably do some simplifying. So as I expand that in the next line, we'll slide this up here now. The limit as h approaches 0 of 16a squared plus 32ah plus 16h squared minus 16a squared all over h. Well, watch this. I have an h here, I have an h here, I have an h here. Anything that does not have an h will cancel. That's no accident. It's rigged up on purpose so that I could do this step. If I factor out an h, I'm left with 32 times a plus 16h all over h. Give you guys a second to let that kind of soak in. Did I do it right? So now what happens is h over h reduces down to 1 over 1, and I'm left with the limit By the way, remember, this is the rate of change. So the rate of change is equal to the limit as h approaches 0 of 32a minus 16h. Well, the limit of this thing is actually 32a minus 16 times 0. So what does that equal?
Yeah, wait, why is it minus?
Why is what mine? Oh, it should be plus. So then what I'm saying is that my rate of change should be 32 times a. But what did we say a was?
One.
Way back at the beginning?
1,
So it should be 32 times 1, or
32.
32. Now what does that mean? The rock was traveling at
32. Rate of change.
32 feet per second.
32 feet per second at 1 second. How fast would the rock be going at 2 seconds?
16 times.
At 3 seconds?
16.
96. Do you see how that works?
Can you just, could you have just plugged in 1 for T and equated and got the same answer? Isn't 16 squared 32?
It's 1 squared times 16, which is 16. This is how you do it. Any questions on that?